Alright guys, so as you can tell I am not in the building today, so we're going to be doing this virtually. I've got this video all set up ready for y'all to go and use, so you'll watch this and do the assignment. Now, we were going to go between chapters 10 and chapter 4. Chapter 10 was going to deal with, not matrices, chapter 4 is dealing with matrices. Chapter 10 was going to be dealing with circles, hyperbolas, ellipses, and all these different shapes, looking at them on a coordinate plane and seeing how they work and how they operate. But we're going to do matrices instead. And we've covered matrices before. We've done it already. We've done addition, subtraction, multiplication. We've seen how it works, especially with the graphing calculator. So we're going to be taking a second look at this here and kind of delving a little bit deeper into it. Now, when we talk about matrices, a matrix is something like this here. We've seen some before. Now they call this one here matrix A. And when we name a matrix, we normally use a capital letter, A, B, C, D, E, F, whatever letter we want, and we name it a capital letter. Now each inside the matrix is going to be numbers. It's made up of numbers. And each number inside the matrix is called an element. And we name elements by using rows and columns. And every matrix is made up of rows, are left or right, and our columns, which are up and down. And each element can be named using the rows and columns by this here. So they have two examples kind of given here. So we have A21 and A32. And when we look at this here, the little a tells us that we're talking about an element, because since the matrix here was called A, capital A, each element will be little a. So here we have A21. And what that tells us is that we're talking about an element because it's lowercase. The number 2 tells me that it's in the second row, first column. Second row, first column. So it'd be -1. Now over here it says the element -8 is in row 3, column 2, depicted by A32. Third row, second column, and we get -8. And that's kind of the gist of it, that we can have a matrix A. It'll have elements inside of it that are made up of rows and columns, and we can use little a to describe or depict which element is in the matrix, and we can name it. So we're going to do some of that there. Now, dimensions, I didn't state it just a minute ago, but a dimension is the rows and columns. A matrix will have dimensions by its rows and columns. So we look at this here, matrix A. It has 2 rows and 3 columns. So when we state its dimensions, we will say this is a 2 by 3 matrix, rows by columns. Now, and that's it for the dimensions. Now the next thing we're going to look at is our element. Now the element again, so we have little a, and little a tells me that we're talking about an element inside. And because since, okay, as I just said, it's little a means we're talking about an element. Now row, column, row. Row, column. Okay, because the first number, the number 2 is our row, and the second number is our column. So when it says 2, 1, we're going down 2 for our rows because the row was 2. So we go from -18 down to 9 because -18 is row 1, 9 is row 2. So this here is row 2. And we go over 1, which just leaves us at 9. So A21 would be 9. Well, hey, look, now let's say we wanted to not just find A21. Let's say we wanted to find A13. So A, again, is talking about an element because it's lowercase. 1, so row 1, column 3. So we'd go first row, which would be -18, 6, 38, and then third column, which would be over at 38. So A13 would be 38 because that's in the first row, third column. And that's all we'd have to do for this here. Let's just look at some more examples of this here. So here we have matrix B, which is given here, 10, -8, -2, 19, 6, -1. And we're going to use it to answer the following questions. Now the first thing we want is the dimensions. So how many rows do we have? 1, 2, 3. So we have a 3 by, how many columns do we have? 2. So this here is a 3 by 2, and that's the dimensions. And that's all we have to do for the first part. Now the second part is asking us to find the value of B32. Third row, second column. So I go down to the third row and over to the second column, which gives me -1. So B32 for this matrix C here would be -1. And that's all we have to do for this here. So we'll do some more examples. Let's look at the dimensions of each one of these matrices first. So matrix A is well, it has 2 rows and 2 columns. So it's a 2 by 2, not 21, 2 by 2. Now if we look at matrix E, well, it has 3 rows and 2 columns. So this here would be a 3 by 2. As well as matrix F, because if we look at matrix F and E are about the same, because they both have 3 rows and 2 columns. Not 3 by 12, 3 by 2. So they would both be 3 by 2s. And lastly, we have G, which has 3 rows and 3 columns. So we'd call it a 3 by 3. And more specifically, we would actually call it a square matrix. Matrix A and matrix G would both be square matrices. Now let's look at this here, A21. So little a tells me I'm talking about the element. 2, 1, so the 2 is telling me I'm in row 2, and the 1 is telling me I'm in column 1. So I go down to row 2 and column 1, and that one would be -3. Now the other one that it asked for was A11. So the 1, 1 is talking about column 1, row 1, or row 1, column 1, which would be 1. And that's all we have to do for this here. Now the next one we have E, little e. So we're talking about the element in matrix E, 3, 1. So row 3, column 1. Well, row 3, column 1 would be 1. And E12 would be column, or row 1, column 2. So we go to row 1, which would be at the very top, and column 2 would put us at -1. And that's all we have to do for this here. Now we move on to F32. So that would be row 3, column 2. So row 3 would be at the very bottom. Column 2 would be farthest to the right for F. And that gives me -4. And then the next one for F is 2, 2. So we do row 2, column 2, which would be 3. That brings us to G. Little g, so we're talking about elements in the matrix G, capital G. And the first one is 3, 3, G33. So the first 3 is our row, the second 3 is our column. So we go to the third row, third column, which would be -1. And lastly, the last one we're looking at on this page is G13. So the 1 is our row, so first row, 3, third column. So first row, third column would be over here, which would give us 1. And that's all we have to do for this here. Okay. Now, we do have some special matrices, and I mentioned one of these earlier. Now, let's look at these here, and we're going to kind of name them. Now, this first one here, we're going to call it a row matrix. And the reason we call it a row matrix is because it has 1 row. This here, if we actually gave its dimensions, would be a 1 by 4. 1 row, 4 columns. Or really any row matrix would be 1 by m. It's going to have 1 row and however many columns. So we can make it as big as we want. We can have a 1 by 1, we can have a 1 by 4, we can have a 1 by 200. It would be a row matrix. Now, taking a guess and looking at this here, you could probably figure out what this one's going to be. This one here is going to be a column matrix. A column matrix because it has exactly 1 column. So this one here, it has 2 rows and 1 column. So we'll call it a 2 by 1, or really we can say an n by 1. Because no matter how many rows we have, we will still have 1 column. So it's called a column matrix because it only has 1 column. Now the next one here is called a square matrix. And the reason they call it a square matrix is because the number of rows and the number of columns that are in the matrix are the exact same. It has the same number of rows and the same number of columns. So this one here is a 2 by 2. Or we can call it a n by n. Because as long as the number of rows and columns are the same, we will call it a square matrix. So a 3 by 3, a 20 by 20, a 200 by 200. It doesn't matter how many we have. As long as the rows and columns are the same, we call it a square matrix. Now that brings us to the last one, this one here. Now this one here, it might seem kind of not obvious, but if you look at it, the only elements that we have are all 0. So we call this a zero matrix because every element in the matrix is 0. So it's called a zero matrix. Now for matrices to be equal, they have to have the same dimensions and the same elements in every single one. So here, our first two that they are given, first two we're given, well, the first one here is a 3 by 2. And the other one over here is a 2 by 3. So the dimensions aren't the same, so they cannot be equal. They cannot be the same. Now this next one over here, we do have a 2 by 2 and a 2 by 2. They are the exact same dimensions, but we run into an issue with the fact that not all the elements are the exact same. Because up here we have 4, and over here we have 6. And in the first one I have a 6 down here, and this one has a 4. So because all the elements inside the matrices don't line up, they are not equal. And for us to say equal, they have to be the exact same. And that's it. That's all we were doing for this year. So this first lesson's pretty short, pretty simple, and I hope you all have a good rest of your day. Now, if you have any questions, please let me know. Please email me, have Matt get in contact with me. So please let me know.